Okay, for people joining this live stream, we are talking about the subject of iterators, which have apparently come up in a variety of different venues, and this is our attempt to centrally talk about them. So, what's the idea?
Right, so there are several levels of structure here, and this goes from the simplest ideas to the more complicated ones at the end, the more general ones at the end. So the first thing I think it's important here is that we have multiple combinatorial constructors like tuples, subsets, groupings, etc. And for some of them, we allow a way of going directly to the nth one, but not for example, for tuples or subsets. So this is something that has been requested multiple times.
Do we know how to do it? I guess with tuples, it's pretty easy. It's just digits.
Exactly. Yes. So yeah, it may be more or less difficult depending on the case, but it's useful for mainly for all those huge cases in which constructing all of them, like all permutations beyond 13 elements, will be way too much.
So, I mean, interestingly, tuples could have another argument, which is basically a take spec.
Could be. Mm-hmm. I mean, I don't know exactly how to do it, or this may be also related to the data structures, because the data structure could contain somehow the symbolic arguments that we provide to tuples, and then they could create fin elements. And in fact, that's a point there. Tom has been working on the particular case of permutations as an example.
Okay, is Tom here?
We couldn't get him today, but
okay.
Yeah. So that's one possible idea. And then the next case, so I was showing there the case of permutation groups, for which we do have an algorithm that can generate the nth element for any permutation group.
All right, so basically what you're saying is indexing into the kth element. So that might be something like tuples of 1, 0, 20, and then 67,000 or something.
Right.
Or some much bigger number. Okay. The next case is finding the next.
Exactly.
And I understand. So it would be something like next tuple from the 1, 0, 20, and then an actual tuple. Whatever it is. Okay. Just where should I save this? Does somebody know?
I don't think you have any place specific.
I'm going to put it in functional programming.
Makes sense. Cool.
And people in live stream, Sander is pointing out select tuples and select permutations in the function repository. And Carl is pointing out that Zabalks had a post about iterators in the community.
Right. I think I have some links to Sander's functions further down.
Ah, Sander himself as the...
Yes, so I think if you open the next section,
okay,
collecting information. Yeah, you see.
Oh, there we go. There is select tuples in the flesh.
Exactly. So this is the next step. I mean, together with the enumeration of the elements of a set, we want to do something along the way of enumerating them, which could be a selection case like this. So it's an operation on each individual object, or it could be something accumulated. Right. So then another thing that has been suggested in relation to these several times is the problem of, well, I have such a long computation that I want to stop it and then continue.
Mm-hmm.
So this is a bit like checkpointing in numerics.
Yeah.
Or it reminds me also about the state of the random generator that we have been discussing recently.
Right. I'm sure there exists some very pure language out there that allows one to stop its computation at any point and continue it. It seems hard to do.
So this is the sort of thing that has to be prepared for each individual function we have. But I don't know whether, for example, our numerics allow this. So Rob is here. Do you know whether we have this sort of checkpointing capabilities?
No.
You don't know, or we don't have them?
We don't have them.
I think they're very hard. Okay, let's look at this general iterator objects.
Exactly. So I
is
think
Leonid here, by the way?
Yes.
Yeah, I'm here, Sam.
Hi there.
Yeah, so I let Leonid comment here. So this is about the more general concept of iterators.
Which you had built for your chunking project. Is that correct, Leonid?
Yes, but here I tried to be a bit more abstract because the iterators that I introduced in the streaming project, part of that complexity was due to performance and a few other things. So these commands here on your screen, they are more towards generic notion of the iterator from sort of programming or software engineering perspective.
But okay. Yeah, I understand. Okay. I mean, this is the concept of an iterator that has an internal state. And that's why it's related to Tom's data structure type stuff. And where you poke at it and it disgorges more tuples or something.
Yeah, but I think this has at least two different levels at which you can look at it. And one is the sort of interface one, and the other one is implementation wise. Because, I mean, if you want to, I can give a very short demo about the interface part of this discussion, like what I mean by that. It will probably take like 5 or 10 minutes only. Because I just ripped from the streaming project just the part that is relevant to this discussion, so I can share the screen and show.
Yeah, please.
All right.
Let's do it. Go for it.
Okay. So let me just switch to the right. So basically, in streaming, the idea I came to is that what we need is more an interface than specific implementation, where you can declare a certain iterator interface.
It helped me a lot to just see an example before we talk abstractly. Let's just see an example of this.
Yeah. So here is an example. I'm basically constructing an iterator just from data in memory, and it just contains some, inert symbol and 4 functions that are starting the iterator, going to the next element, checking whether it's active, and closing the iterator. And so here I'm taking a range of 100 and I'm creating an iterator from it, which is the object myListIterator. I can check whether it's active or not. So currently it's not active. I can also check what is the end value, and this is something that tells it to stop. And then I can init it, it becomes active. And then I can start calling iterator next on it to getting, parts of these range 100, or doing it like that and computing the total of those chunks. And then finally,
wait, stop. What just happened there? So iterator next fundamentally just pulls a new chunk from the iterator. Is that correct?
Yeah.
Okay. And the iterator is, in this case, for implementational purposes, it's chunked.
Well, yes, this particular one returns to you lists of elements. Yes.
Okay.
It doesn't have to.
Well, I understand that, but although the most natural next would be a single element, but for implementation reasons, you want to return chunks here.
Yeah, I just chose this example, but again, it's not really important.
Okay.
We could also return other objects.
Okay.
And so then you can close the iterator, and if you try to...
Yeah, I get what would happen if you close it.
Yeah.
Show me something more exciting.
Well, this is like same thing, but here I'm getting the
it's
same.
file backed. Yeah.
Yeah. But what is important is that this still, it obeys the same interface. So I don't really care from where this iterator comes, whether it has been implemented from a file like here or from data. I can just use the same interface where I basically create an iterator from a file, then I init it.
I understand. Okay, so the immediate idea this gives me, and it's really a shame that Tom isn't here, is that in the new data structures project, we could have an iterator data structure. And one thing that hasn't really been looked at with respect to data structure is its interaction with external things like files. Because I could imagine a, given that it's maintaining a stateful interface, it can maintain a file pointer and so on. Yeah. And this idea that you could have a data structure that is an iterator, or let's say a file iterator, that just allows you to read stuff. Yeah, this is interesting.
Yeah, but still, just
I mean, in a sense, we already have an iterator concept with the incredibly low-level, file reading thing with file pointers, don't we?
Yes, but it has a different interface. And I mean, the main idea I was trying to convey here is that the important part of this thing is the interface that I define here. Well, I don't really expand what code defines that interface, but basically the different implementations, they simply obey, like they satisfy the same interface, the same contract. And that's what makes it flexibility, because it doesn't really matter from where.
I understand. It can be file backed, it can be memory backed, etc. But
yeah,
I mean, in your concept, the thing you have is a thing that has the idea of a next element. Yeah. What else does it have? I mean, it's kind of a linear object with a next element concept.
Yeah. So basically, you need to define 4 functions: the initializer, the function that just returns the next element, whatever it is, then the function that checks whether this thing is active, and the function that closes it. That's it. So if you define these 4 functions, then you basically define this interface, implement it.
Okay, but I think you're talking about something a little different than, okay, so that's interesting, because one could imagine, but now, okay, the work that you did on the streaming thing involves being able to do operations like take a mean or something of some giant data set with 1 billion elements.
Yeah, sure.
How does that relate to this?
Well, I can briefly describe that. So basically, yeah, let me just show you. So first of all, yeah, I just need to come to the right slide. I am using several types of iterators in streaming, and they're all based on that kind of idea. One is that I can create this lazy list object from the iterator over data. So this way we abstract over the specific source of data, whether it comes from data that exists or that is materialized at some later point or whatever. But then there is another idea where I'm using it because I'm chunking data. I actually am using iterators of chunks. So in this case, for example, I'm getting some, iterator that is somewhat different one. It's data chunk iterator. So instead of, it's again the same interface as you can see, init, next, and so on. But now instead of returning, some simple list of data returns objects which are called data chunks and which have their own more complex semantics. So basically, the way I'm using it for streaming is that I'm using chunks to make it fast. And so the data or the file, whatever is getting into the system, is getting chunk by chunk, so we never use too much memory. On the other hand, in the chunk, I can use vectorized operations and make operations really fast. So I mean, I am using this iterator interface in several places in streaming, but of course, streaming is much more than just this simple idea that I
I
mentioned.
think one of the killers so far for streaming has been, what is our source of data? Because, go ahead. I mean, it's like, where do we find big chunks of data that are already digested?
Oh, there are plenty. It's just that, well, you might not remember, but there were some technical issues other than that we also encountered, and which probably would take like
well, okay, but
several months.
one of the things that one of the problems that I had was, okay, what is that data? Is it a CSV file? Is it an HDF file? What is it in the wild? If we wrote the data out, that's one thing, but if it's coming from somewhere else.
There are several sources. One can be huge CSV files. They do exist. Also, in the databases, now that we have this connectivity, databases might contain lots of data. And in some cases, it might be conceivable that people might want to actually get lots of data into Wolfram Language.
Well, but I mean, right now, the operations on databases, it's the database server that is doing the totaling of a column or something like this.
Yes.
Not going through something. I mean, but let me ask this question: if we wanted to do something which I keep on being told is impossible, that is to do arbitrary operations on large amounts of data on the database, is streaming a possible approach to doing that?
Yes, I think so, because basically, if you want to do something more complicated in databases, there are only two choices. Either we somehow support some callbacks from database engine into Wolfram kernel, which are, I think it's
well, that's not going to work, because if it's a billion row column, that's going to take forever to do callbacks.
Yes, right. Or we do something like what streaming does, and then so basically then the procedure is that you load lots of data into Wolfram Language in the streaming format, because streaming format basically saves them on disk in chunks, so you don't have to load all of them in memory. And then
so then what you're proposing is the database writes this out in some format that is it writes out those billion rows somewhere, and then we use the little kind of streaming head, so to speak, or maybe multiple streaming heads if we could do it in parallel, to go and sort of crawl through that big thing that got written out. How would you write it out if you were going to do that?
Well, you mean syntactically, or
what would you write it to? I mean, what would you write? What would be the structure that you would write it to?
Oh yeah. There is already a format that I implemented when I was working on streaming, which is basically a collection of MX chunks. And now instead of MX chunks, there could be, for example, WXF chunks, and that might be even faster.
So in other words, what you're saying is, if we made an interface between databases and WXF, we could write out big chunks of stuff from the database in WXF that could then be resident on a disk somewhere that we could then read. That's interesting.
And it's actually, it's not that much work already, because streaming does most of it. Basically, that same iterator thing I was showing to you, we could just create another iterator based on databases, which will be more or less implementing something similar to this. And then basically streaming could consume it and create those formats on its own. So
okay, so bottom line, if we wanted to have an arbitrary function inside entity function, would this allow us to do it?
Yes, except I have to say that because obviously this will only make sense for really large amounts of data. streaming so far is somewhat limited by what, like, even though I'm trying to use like as fast things as possible, like vectorize operations and so on, I think like if you're asking about arbitrary things, they'll be only as fast as we can make them to be, because they'll be using top level code.
Well, hopefully compiled code.
Yes, yes. If in fact streaming allows you to insert compilation inside the stuff that you're putting in, so it's not very difficult
that's
to
interesting.
do. Yeah.
All right, great. Okay, anything else we should see on your screen, and then let's go back.
Oh no, I think I've shown most of what. The only thing I wanted to add to that is that I think if you want to make things performant, then chunking is essential.
Okay, I understand. All right, what's this about? More on lazy lists. Okay. Okay.
Yes, at the end, there's this connection with another thing we have discussed multiple times, which is infinite lists.
Yeah, what happened to that chap Luis's infinite list thing? Is this a upgraded version of that, or is this a completely different?
I think this is a different approach. That was more like a symbolic list.
Yes.
Approach, which is something else we have discussed several times.
Oh, by the way, streaming does support infinite lists to some extent.
Right. I'll just mention another, this iterator thing you have is quite nice, Landoid, and an example of something you could do with it is you could put a random number, Jose already mentioned the random number generators. So that in effect is an infinite list too.
Yes.
And his iterator struct, you could put in a random number generator. For example, you could make the in condition that the sum of the numbers added up to a certain amount, and that would quit there. So there's lots you can do. It's a very nice idea for a general structure.
Say that again. Explain this again.
Okay, so with his iterator struct, if we had a way of iterating over things, I could set the in condition to be, say, the chunks would be chunks of real numbers, okay, that would be generated. You could set the in condition to be that the sum of all the numbers generated added up to a certain amount.
Why is that a good idea?
Well, it's just an example, but it's a way you could get n random numbers that add up to some number m.
Great. I mean, yes. Okay. Sorry, I apologize for my lack of enthusiasm, but I don't understand the point. I mean, yes, that's the thing one could do, but so what? I mean.
Well, I guess I'm just trying to emphasize that this idea is very general. I mean, it's
right. But so,
and doing tuples or this or that.
Right. Mutable iterators is the concept of some kind of thing where, like, I don't know whether I can demo it. Is data structure in the X kernel? Does anybody know? Anybody have any idea? Does anybody know whether Tom has put that in? No, complete silence. Do we try to reach Tom? Is Tom not available?
Yeah, I tried to reach him multiple times, but didn't hear anything.
Oh, that's a good sign. Well, I have no idea whether this is going to work, but is this doing anything? I think it's called expression linked list, maybe. That's encouraging. Anybody know how to figure out the operations that this thing does? Great. Well, let's just try. That's encouraging. Okay. I know it is sending me something, but maybe he could send me something more. Okay, so anyway, so I mean, if you haven't seen this, this is let's see, this is, you know, this supports certain operations, right? I think there's a better form of it that is right, and so I could imagine that this is something. Okay, so now if I say ds there, hopefully it'll have length 100,000. Not bad. And I would guess that I can say, right, so I mean, this is a mutable data structure, right? Makes sense. And I'm thinking that that is similar to what you are referring to as an iterator. Yes, no?
Yes, I think Iterator was one of the structures Tom had in mind.
I haven't seen it on a list. I haven't seen that on the list. So I wish he was here. I wish we'd arranged this meeting at a time when he could be here. It's kind of silly not to. Whatever. If we just do this, like, let's say, I mean, there's nothing to discuss with this. Okay. I don't know how you do this. I think maybe there's a thing that says operations here or something, but this isn't the way it was supposed to be designed. No. Oh, there we go. Okay, so I doubt this is of any reasonable. I doubt this is all reasonable yet. Okay, doesn't look very good yet. But what's my point here? My point is, from what you're describing of iterators, I don't see why that shouldn't be supportable in this framework.
I think it definitely can be.
Okay, so maybe we should just implement it there. So we've got the wrong people here, but maybe this is what we should be doing, is getting, you know, as one of the collection of data structures, getting a thing that is an iterator that supports Leonid's operations, right? I mean, it's basically what it would be, and that, you know, would be the analog of expression linked list. It would be expression iterator. I'm not that keen on the name iterator because I think we've used it for other things. And to me, it is not an iterator, is not the repository of the process of you know, getting things, but that would be something which would support the operations that Leonid has described, you know, next, etc. Right? And presumably this iterator would take in something like a file or an existing expression. Am I correct? It could also presumably take, in a much more advanced world, it could take a symbolic thing like tuples. It could take an unevaluated tuples and then iterate through it. I mean, that's kind of the concept here. That's the unifying idea, is that you could do these operations here. I mean, Leonid did not discuss this operation, for example. He discussed this operation.
Yeah, but in fact, Stephen, I didn't show that, but on Stack Exchange, there are a number of examples where people already did use streaming, even though it hasn't been documented, and extended it with fast generation of certain things like tuples and more complicated combinatorial sequences. And they were showing very good results in terms of speed and memory usage. So,
well, okay, but explain to me the top-level design.
Well, the top-level design is that basically, as soon as someone creates an iterator of certain things like sequences of combinatorial, sequences or whatever, it can be fed to streaming for efficient processing and for whatever streaming can do with it, but it can also be used on its own. So as soon as we have this iterator thing, we could, if it becomes a kind of an interface so that people could contribute their own implementations, then all that will matter is that it obeys the same contract in terms of supporting all those methods. and people could just implement, we or other people, whatever solutions they have, and they could be used interchangeably.
Okay, but look, so just to understand the type of thing we're talking about here, I mean, this could be things we could imagine are things like file blah blah blah, some WXF file. Is that what you have in mind? That then, if we have that expression iterator that refers to this thing, then this is, this mutable data structure contains pointers and things like that to different parts of these different parts of these structures. And presumably the concept would be that in some future compilation world, I mean, this is sort of combinatorial compilation, so to speak, that you can take these combinatorial constructors and turn them into something that is capable of being symbolically iterated through. Is that right? And
yeah.
That then turns into, in the case of tuples, that would turn into an nth element selector in the tuples.
Yes. So, I mean, for me, the most important thing for thinking about these things was to realize that the iterator thing that we want is more an interface than an actual implementation. So that basically...
I understand, but that's what this, I mean, this thing here, something like this, for this, for example, the implementation is non-trivial to figure out, if I were to put instead there, I don't know what, I could say permutations range of 100 here instead.
Yeah.
Right. And I mean, the concept is these are sources, just like the file is a source of lots of stuff, or as Rob has been suggesting, something, I mean, this is very strange, but something which is essentially random integer becomes a source there. Although that's I mean, there's a question of what are the sources of large amounts of data, and one of them is the internally generated symbolic expression. Another will be a file. Right, but I mean, I'm confused. Okay,
there is one. So in Python, there is like this construct that is built in the language, where basically you define a function and you yield value. So instead of return, you have some kind of arbitrary code that is just sending values out. The way I was thinking this could be done in Wolfram language would be, imagine something like rip and sew.
Okay, so wait a minute. So what should I call this section here? This is some symbolic thing, I'll say for now. Okay, so what's your idea?
Yeah. Imagine something like rip and sew, but every time where you can do something like while true, so something. Now, obviously, like if you evaluate this guy, it will never go through, right? But you can imagine something where every time you hit the saw, you stop the execution, right, until someone else is requesting the next value. That will be something very easy for people, I think, to write.
I'm not understanding how that would really work. So what you're saying
I have no idea how this can work, but in theory, like this is something I would imagine people would use.
So Jalil on our live stream is talking about monads. Always, who understands Pascal monads here? Or do we have the wrong set of people? That was bad. That there's complete silence. We may have the wrong set of people, but that is, I mean, who here understands how Haskell deals with lazy evaluation? Because that's essentially what you're asking for here, right, Ricardo?
No, this is not quite that, Stephen. I can somewhat explain.
Okay.
The problem and why I think it's not very realistic for Wolfram language right now is that Python allows you to do that because Python has the notion of coroutines, which are functions where you can pause the execution of a function and basically instead of discarding the stack, the execution stack, you keep the reference to that stack in the stack frame. And therefore, you can resume that execution at arbitrary moment later. This requires very heavy language support to be possible.
So there are languages like Go or something which specialize in having that kind of stuff, right?
Yeah, I think Go has Go routines as well. Yeah.
Yes. Well, they call them Go routines.
Yeah, Go routines. So the other problem with this approach is that in Wolfram language, every iteration that goes through as element by element without chunking is probably going to be slow unless it is compiled. And so this form will anyway have to be rethought. Even if we somehow manage to do that, it should probably return chunks.
Wait a minute. You're saying multiple different things here.
Yeah.
So compiled code is much more amenable to coroutine type execution than the full top level story, right? So it's much more plausible that we could take a piece of compiled code and run, and the execution engine for that could use coroutines.
Yes, but these will not be Wolfram language coroutines. This will be lower level coroutines.
Sure, but the compiled code, if there was a language construct, boy, it's so, back in the time of SMP, back in 1980, I had this function called fork in SMP that, anyway, long, painful story of early Unix systems and things. But in any case, let me just try to understand what the language construct would look like for the thing you are describing, for the coroutine thing that you are describing. I understand that we couldn't implement it right now, but what would it look like in principle?
Well, basically, instead of normal return in any function, you introduce a new keyword, which is called yield, as Ricardo pointed out.
It's embarrassing that we don't even have coroutines in our spelling dictionary. Let's go for. Can somebody report that to the spelling dictionary, please?
Yes, got it.
Okay, go ahead. Yeah.
And so there is a new keyword which you should be able to insert virtually anywhere in your code, and that will work almost like return, except you can return several values within the same function. And every time when you do a return, it kind of gets frozen. The code, like imagine the whole execution, the code, the stack gets frozen until the next time you call it. And then it returns the next yield.
So we have some function here, and it's, let's imagine just it's a pure function, and it has things in it that say yield. And yield as in don't yield to another stream of traffic, but yield this result, correct?
Yes, and you can have multiple yields, like you have, say, yield and then another yield.
What are some other names for yield in other languages?
I think it's always, in JavaScript, it's also yield. In Go, I don't know.
Okay. All right. Anyway, so what's that?
We might think push. Push might be another name.
Okay. All right. Yield just confuses me because it suggests that, yield is also punning on the fact that it is yielding control to something else, right?
But it's true. That's what it does.
I know that. I realize that.
Okay.
But the primary, so what you're saying is this has the state of this function with this thing ready to be returned.
Yes, but then if you have something after yield, like some other statements and then maybe another yield, then those will wait and execute next time when you call this function. So when you resume it. Yeah.
Yeah, if you got a print between them, you should not see them. If you just what Python does is provide you a function that is built in also that is called next. And you can call next several times over a generator, and at the end it will return to you either raises an exception, something like iteration stopped, or returns to you like a particular value.
Well, okay. Look, the fact is we have something different, which is instead of a stack frame, we have the ability to store what's going on symbolically. So it's not obvious that there isn't a similar construct. I just don't know what it is. Right? So imagine that you have this thing. Imagine this function is So you're saying you call this function once and it returns X, you're saying.
Yes, and then it stops exactly after that statement and waits until you call it next. And when you call it next, it resumes exactly from the same place. So then it will echo and do another yield and then again stop.
Right.
Well,
So I mean, in our world, right, it, you know, the function could return a, you know, in the immutable world that we live in, okay, the function could return something that basically says start here. Could return a new version of the function that says start here if it wanted to. Right. So in addition to returning X, it is, well, if in a mutable world, this would be rewriting this function to say start here.
How would you do it when you have a while? Where do you start? I mean, probably you start again.
Well,
yeah,
you're saying if there's internal state in the function, but the whatever happens, that internal state, you're saying inside the while you have a yield, right? And you're saying,
exactly.
How does it know what state the while was in when the yield happened? Right?
Yeah, it will be hard to transform this into kind of symbolic, you know, pure function thing that would carry. It's like continuation passing style in some sense, but
yes, right, it is. Yes.
But it's kind of a hard transformation from iterative code. So I mean,
well, I understand that, but most of the code that we care about isn't, you know, is more like functional code rather than, you know, people writing for loops. I mean, clearly it could be done in, you know, if you say do it in while, it obviously is doable in while. But the question is,
well, it's true that, like, for example, in Python they have this concept of coroutine, but every time I use them, I use them all the time because, like, you don't use memory, but in the end you always iterate them through the end. I mean, it never happened to me that I was using next manually or that I need to do, you know. So those kind of functionalities needs to be there, but then at the end, people will always iterate it. You know, they will join iterator, they will do a select over them, you can map over them.
okay, so just
and you do
explain
all
to me.
kinds of operation, but then at the end you always do it in one shot in order to save memory. You never, you know, manually call next and really care about, you know, doing this.
So explain to me then what the bottom line is for what you actually do.
Well, the bottom line is that okay, for example, you can connect to a database, and when you iterate a query in Python, it will return an iterator, and so you can iterate this guy one by one, and you don't get back 10,000 results. And then you can do operation over those 10,000 results by just, you know, iterating one by one. And
I understand. So it's the same concept again, that you have, you know, this expression iterator, and what you've got there, you know, another type of thing that you have is some kind of database query here.
For example, right. Yeah, I mean,
right.
that is one example of iteration.
Just to understand, you know, just to understand the concept again, we have a source. So I don't know whether this is relevant here, but the, you know, the fundamental thing, we have a source of large amounts of data, and the issue is, how do we, you know, how do we process that data without, you know, having it all in memory, or, you know, or even necessarily generating it all, right? That's the general problem we're trying to solve, correct?
Yeah.
And, you know, some version of this is the data exists somewhere, like it's in a file. The data doesn't exist. It's symbolically represented by a huge tuples or something, or it's something like random integer, or it's potentially a generator here that is some kind of what can we do? You know, it's a it's a recursion relation of some kind. You know, it's some, you know, some kind of recursive thing that just is computed from things before it. where we're kind of toast in terms of where we can only go forwards, right? In the case of tuples, we can imagine some math that lets us dive into the middle of it, right? In the case of, if that recursion is Fibonacci, then we know how to dive into the middle of it. Am I making sense? But there are plenty of recursions we can imagine where this is the world of computational irreducibility, basically, where there's no way to dive into the middle of it. Am I making sense? So for example, let's take this example. Actually, a really good example. Let's take the center column of Rule 30, and let's say, we've got this, and we've got we've got Rule 30, and we've got let's say, yeah, there we go. So that would be let's say 100 steps there. Okay, there they are. Now let's say I want steps. Let's say I make this be 10 to the 8 or something, and then I hold that, and I now say, okay, give me steps number such and such through such and such. Am I making sense? So I just put up these prize problems for whether that's possible, so to speak. Am I making sense? So in other words, there are functions you can define here where jumping ahead is sort of guaranteed to be impossible. There are other things like a file where, yes, you could jump ahead, or random integer, you probably can't jump ahead. If it's a supposedly cryptographically secure one, you shouldn't be able to jump ahead. Okay, so we got things where you can jump ahead. You've got things where you can't jump ahead. We've got things where you can chunk read them. Am I going in the right direction, or do people think I'm off track here?
I think this is the right direction.
Yep.
Yeah.
And I would expect also to be able to put these things in the second argument of table and do.
Right. I see what you're saying. So in other words, so uses of iterator data structures. So you're saying I could say table, blah, 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 iterator. Or you're saying, and that this is really, or you're saying it's a part iterator, blah, blah, blah. That's the, that's select the nth element of the thing. Or you're saying it's select across the iterator with a criterion. What else would you like to be able to do?
I was thinking of table of XXX, I, iterator.
Yeah, exactly. That's what I had in mind. Yes.
Yeah.
Sorry, I was saying map and scan, obviously.
Yeah, but that's not so useful because,
Well,
I mean, clearly, look, these are, okay, look, these are whole gulp functions, right? And these are sort of small byte functions, which are different, right? Because that's really going to be, something like map. Well, scan is a sort of a mixture, right? Because it's
Stephen, let me interfere for just a second. I think iterators should have absolutely minimal interface because something like streaming was created exactly for more sophisticated operations on iterators effectively, like Spark, like map, like all these things. And iterators themselves should be doing the minimal number of things they can, like more or less that interface I was showing.
Yeah, I understand that, but I'm trying to understand. Great, so this thing here is an iterator, right? One of your iterators. Okay, so then scan just, eats in little pieces of the iterator, going in, in chunks or whatever else, and doing its job. Why is that different from what I'm showing here?
Let me explain. Iterators are, I think, they are stateful and exhaustible. And so you do this scan once, and then someone tries to do it next time, and the iterator is already closed.
That's a different thing, right? But I mean, so that's this case up here, right? Where, I mean, that's the file pointer idea, effectively. If an iterator was in a file, referred to a file, it's moving the file pointer.
Yeah, but in general, it has to be, I mean,
No, it doesn't. No, it doesn't. I mean, in this case here, it doesn't. That's a different thing. You know, that's a case that has the same basic semantics, but it works differently. No, you're not going to exhaust the tuples, so to speak.
yes, but I think we should distinguish between iterators that are still sort of mutable, and for tuples, it's more like a lazy list of tuples, which you can access at any point. This is not exactly the same.
Well, I don't think this is correct. I mean, I think that look, take the case of a file, right, where it is in some sense exhausted because the file pointer just walked down to the end of the file, but you could also move the file pointer back in the file, probably, unless the file is some kind of stream where you can't do that.
Yes, but given that example with the file pointer, if you take, like, for example, table of something with that file pointer and you run it once, then you can probably reset the pointer. But from just looking at this, you wouldn't know that you have to. And if you repeat it twice, the second time it will break.
I'm aware. I'm aware. I think that's kind of cruddy design, actually. I mean, I think that, look, you're saying there is a mutable thing that you can sort of progressively consume, and then you've got to the end of it. I get it.
Yes.
That's a sensible thing, right? But I don't think you should say that's everything that we have to talk about.
Yes,
I don't think that's the most important aspect of these things.
But my point is that the other things that you're mentioning, where you can reset things, go back, have random access, they are already somewhat different data structures, not iterators. Maybe it's a terminology, mismatch.
I think this is a matter of remembering history. So whether we have an iterator that remembers what generated and then it represents a whole list all the time, independently of where it is in the generation, or the ones that do not remember what they generated. So each time you call them, they represent the rest of the list.
Right. Well, that's mutable versus immutable. But I would say that more consistent with our language would be to have table and scan. When they work on an iterator, they actually work on a copy of the iterator. So they basically, but we already localized the I in table. Why couldn't we localize the iterator as well?
Yeah. And that's what streaming actually is doing. That's why I try to distinguish these things, so that these functional operators should work on things which are not really exhaustible, which are maybe based on exhaustible things, but as you say, work on copies all the time.
We have a bunch of interesting comments on our live stream here. All sorts of things. Let's see. Things about threading, chunks, chunk sizing, yes. Sandra is asking if table with tuples is optimized. I'm afraid the answer is no. Yeah, Sandra is mentioning something he had mentioned to me previously, which I thought was an interesting idea and which will probably come up in a different meeting because I know I sent it in, about having tables with associations, which I like this idea, and I maybe it'll even be in the very next meeting that we have this idea. I don't think it's relevant specifically to this. Jalil is talking about monads, and unfortunately we have a bunch of Haskell enthusiasts and experts in the company, but none of them are in this meeting. Handling, processing, sync, async, state, or other type of data. Ethan is talking about paging through a PySpark data frame, where the bottleneck is processing time per core and might be asynchronous. Yeah, let's see. Synchronous and asynchronous. Well, yeah, that's the synchronous asynchronous story is again related to this, gulps, bytes, question of whether you copy, question of whether things are immutable, question of whether you're, Right. Closing a socket stream operates on the stream itself, but a reader that maps over data as it comes in operates on the data inside. Indeed. Yes. Well, okay. So just to try and I mean, okay. So clearly we can have an expression iterator structure in Tom's data structure project, and that should be able to happen quickly. And the question is, what can it operate on, so to speak? What is it being fed as its iteratee, so to speak, as its source of iteration content? What do we think are the top things for it to be being fed, right? Because, you know, we could feed it a generator function. So, Leonard, you have defined. So let's look at, you know,
it really depends what is returning. I mean, what does select of iterator criteria returning? Another iterator or a list?
I'm sorry, what are you saying?
What is select of iterator returning? Is returning another iterator, I guess, right? So you need to have.
I think it has to, but okay, if you want that to work, but that's a much more advanced thing. I mean, in other words, okay, so look, there's a sort of symbolic operations. Okay, so this is a whole different story. Imagine you have an iterator and you select on the iterator, iterator structure, let's say. Select on the iterator structure with, you know, hash greater than 0, and you say that is going to return another iterator structure that has in it the extra condition that, oh, don't return anything that's less than 0.
In fact, it's not so difficult to implement. I have already implemented that in streaming for iterators. It's really not that hard.
Okay, so what you're saying is, what this is doing is it pushes, you know, this effectively pushes the select inside the next function of the iterator.
Yes.
Okay, fine. I don't know what else you can push inside. I mean, there's presumably a calculus of what you can push inside the iterator.
You can do a limit, for example, by limiting how many elements you want to return, or you can do join, where you take two iterators.
Our kind of join?
Just the usual join, just like as if you would have lists, but lazy. So you join two iterators, you get another one which will first exhaust the first and then exhaust the second.
I understand. Yeah. Okay.
Stephen, I have sent you an email with an idea that was a couple of years old. I think it's relevant. There is a notebook.
Okay, hold on.
Mm-hmm.
But just to repeat a little bit about all
I remember this, Ricardo. Yes. Okay. Thank you for bringing this up. It's a pity this wasn't on the. Was this known to Jose in this setup?
I forgot to send it before this meeting. Yes.
Brilliant. Okay.
We discussed it at some point.
Okay. All right. Okay.
Yeah.
So let's take a look at what you've done here. So
I mean, the idea here was very simple. Basically, it's iterator. It's all flat. And it's very nice because you can just join those two expressions together.
Hold on. I just want to save this in the right place. Let's see. Yes. Okay. Let's go back to your demo here. Yeah. Okay. Go ahead.
Yes. I mean, there was an implementation that was not really working perfectly, but I mean, if you run it, it should still work. So, yeah, iterator is all and flat, and so you can just. So if you do normal, it's doing the evaluation.
Okay.
And you see that you can join those two expressions. So
what does this mean? Hold on. What does this mean? This means.
Yeah. This is yes.
This is prepping the iterator. Yes. It just runs.
When you do normal, it's returning true and false.
Okay, so how does this relate to what we're seeing over here with these data structures? This is a very similar thing.
The immutable version of an iterator. I mean that is an immutable one, because every time you you iterate it, it will start from the beginning.
Yours,
it's in this implementation.
yours
Yes.
is.
Yes.
Right. Okay, but so what you're doing here is you are having essentially this is a symbolic so in some sense.
Yes.
So,
and there are a couple of operations that are implemented, because I think like the basics operation that you need in order to implement everything else is just select map and a reducer. And with those three operations that are done lazy, I think you can implement.
okay, so wait a minute. So this is symbolic creation, but this is essentially procedural creation of a symbolic iterator, I claim.
Yeah, and the problem is that, as Leonard was saying, like this is impossible to stop. But if it really depends from the design that we want to do, because if the design constraint is we don't want iterators to be mutable, then this one I think fits nicely.
Okay, so hold on. So this is essentially what this is, if I might understand it, is this is a sort of push into, in a sense. If I have an iterator, which is some symbolic expression. If I say push into this thing, I get back an iterator, correct? This is like an append to.
You might, yeah. And basically that will join the iterator with just a new iterator that is just containing push off. Yeah. Mm-hmm.
Right. So, okay, so then this is, and so normal of that, as you say, is just unravels it as a list. Right? But the whole point is what you could do here is you could say push into, iterator, and then some kind of thing, maybe, although I don't really know how it splices, a hold of a giant tuples.
Yeah, but that will return. That will not mutate the previous one. It will return a new one.
I understand. I understand that it's I understand that it's taking this. Well, you could make it right. The question of whether it's mutable or not is a different question. But what this is doing is it is appending to the symbolic structure this thing that is hold of tuples, and then it is allowing you. It has certain operations for eating through this thing. But again, we're back to the same question of there are things like a file that we, and it's again back to Leonard's point that there are certain primitives like get the next element, let's see, okay, we have a bunch of interesting comments on our live stream here. Like is Jalil is saying like is a map. So for the iterable. Okay, so he's saying given that map hash plus one on iterable returns an iterable thing, and whatever you call it, an iterator. Yes, I agree. That is a symbolic transformation on, that's what we're talking about here, a symbolic transformation on that up there would be a symbolic transformation on an iterator. That returns an iterator there. That has then figured out how to add one to every element, even though it never looked at every element. That's the point. That's the key idea here is, turns into an iterator, and this happens, even though it doesn't look at each element.
Actually, that's precisely what lazy list construct from streaming is behaving like.
Okay.
Because it does exactly this, except I also introduced chunking in there. But that's a detail.
Yeah. I completely agree that the idea of each function having to have its own special thing is hopeless. The difficulty with some of these things, the question is, can you make it so that an arbitrary function, I mean, you could presumably make in our world up values, then to insert this in is not difficult, and some of these things will be compilable, right? So in other words, if the operation is f of iterator, if f is compilable, then that's absolutely something that can be efficiently done. And if f isn't compilable, well, sorry, it'll have to run not compiled, but that's okay, it'll still work.
Yeah, that's exactly how streaming works. Whenever I see the listable or vectorized operations, I apply it.
Right, but so the point is that there are certain operations that are very special in iterators, like the kth part would be something that we would, there's some operations that would be sort of deeply built in. Again, there are operations like okay, wait a minute. So first point is listable operations. Actually, that's not even really the point. I mean, there's listable operations are rather straightforward. It's very easy to understand what they would do, right? They're just applying, if f is listable, then f of an iterator is just essentially mapping f over the elements of the iterator, right? Whereas something like this would have to have special code effectively to handle what you do with these iterators, particularly when you have more than one iterator in an operation. Am I making sense? I mean, and I'm sure, more complicated cases are things like, if I did map thread across two iterators, that would get complicated, right? I mean, that could be made to work, but it's not obvious. You have to have a correspondence between the iterators and so on. But many operations would then just work. But now the question again is, in one of these iterators, okay, so how do you get things into an iterator? How do you, and so Ricardo has the suggestion of the, procedurally pushing things, progressively pushing things into an iterator. That's one suggestion for how to get things in, right? Another suggestion is it comes from a file. Another suggestion is it comes from a symbolic structure, or it comes from a function.
Yeah, I think like if you use the approach that you give me the index and I'll give you and with a function I produce the next one. This is an iterator that you can ask like any point of this iterator, and and you don't need to construct everything else, right? Unless it's something like Fibonacci, where you basically need to know the previous one.
Well, Fibonacci is not a bad case because Fibonacci is mathematically solvable. The bad case is Rule 30, where we believe it isn't mathematically solvable.
Yeah.
Right. So
and that is the case of an iterator where basically get all the features. The immutable one, at least we start implementing coroutines. Basically, it's an expression and needs to evaluate until the end, so you cannot really stop it. The problem, like for example, you cannot do operation like transpose in this case, because if you have like two iterators and you need to transpose them,
you can.
Why can't you do that? That seems like that's very much the same as the join operation. I mean, these are, or map thread, transpose of two iterators is just going to be, I mean, there's obviously, it's not obvious that they're not ragged and things like this. I mean, for example, if those iterators both have next generators in them, what is your guarantee that they actually line up? And so that the usual transpose operation would actually be meaningful. Do you get what I'm saying?
Yeah, but you can define, I mean, as long as you somehow can check that the length says the same, you can proceed.
Well, right, if you have a length operation that's defined, which you may or may not have. Jalil is mentioning the concept of maps and actions. And yes, that you can define something symbolically. In our world, it's symbolically. In other languages, it wouldn't be symbolic. And that then then something causes it to actually unravel and stop being lazy and actually do something.
Stephen, sorry for interruption, but I have a suggestion. In case if we continue these meetings about iterators, because I've implemented already a bunch of these things in streaming, I could give a short demo for like half hour, maybe less, explaining how these things already work within streaming and trying to keep away from too technical details, just, the main thing.
That would be useful, but I feel like, I mean, for me, I'm just trying to understand the thing which really stopped us on the streaming project, which was, where does the data come from that you are streaming in, right? I understood from before, from several years ago, how effectively you can work with chunks. Once you have a data source that you can stream in,
yeah,
it's all good, okay? The problem is, where is the data source? And to me, we've now defined here a few places which all have different characteristics of what those data sources might be. And to me, it's, again, I would like to see, and it's really a pity that Tom hasn't been here, but I would like to see Tom put into his data structures collection an expression iterator that, I'm still trying to understand. I mean, because again, there are these different sources. Let's just make a small list here. Sorry, I'm going to of sources of material, sources of content for an iterator. Okay, and let me just put this somewhere so I remind myself what that list is. Okay, so one source of content is essentially symbolically defined collections. Okay, and an example of that is hold of tuples. Okay. Another example, another thing is sequentially computed functions. And an example of that is our friendly cellular automaton. And these cannot be or a random number generator, right? So these cannot be shortcutted, right? There's no way to get the nth one of these. There's an intermediate case between these, which is symbolically defined, quote, solvable cases. And an example of that would be Fibonacci. Okay, well, we can just solve it with rsolve and get the nth term. Okay, so another source here is, yeah, okay, and this one also we've got hold of permutations of range of 100. Okay, so another source is data from a file. Okay, another source is data from a streaming data source, e.g. an IoT device or something, where the future is not knowable, i.e. where the past might be stored, future is unknowable until it's ready to come in. Okay, let's see. Another case is data from a database, right? Which is sort of, which is probably more in a single chunk than the stuff from a file even. Okay, so another case is symbolically inserted material. So that's the case where we're doing push to of the iterator, blah, 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 right? Or procedurally, we could even say procedurally inserted material. Okay, what are we missing? Ethan is saying on our live stream, the source of content, anything that is enumerable. Yes, but we need to break it down a bit more than that. Yes, I mean, so okay, so what kind of thing are we missing here? Because I think we need to understand that some of these have the property that you can get the nth term and some do not.
Yeah, so I was saying like the case where you have like while true and you do things, and unless you count procedurally inserted material in.
No, I think
the
that's a
diagram.
finite. This in this case, I'm talking about finite procedurally inserted material. Okay, so then there's then there would be the case of, which I don't really understand very well, of infinite procedurally inserted material.
Well, doesn't need to be infinite, but I mean, let's say that I'm just implementing data from a file by myself. I just do, open file, and then I read the line, and then I push the line one by one without blowing up the memory. That is fine.
But no, I don't understand. Then you've got, okay, that is essentially defining a raw next operation, right?
Yeah, unless, I mean,
right. So that isn't that's that's a define your own next operation, right? Which is in a sense lower level than any of these. Many of these could be folded in to define your own next operation. But by the way, define your own next operation isn't relevant for this case here as such. Doesn't need to be. Right? This is non-trivial to go from that symbolic expression to a next operation. It can be done, but it's non-trivial.
Yeah, but that's exactly the whole point.
What?
That in order to form the iterator, you need to formulate what the next operation is.
No, I keep on saying, yes, that's your version of what an iterator is. This meeting started by discussing things that are like this, okay? And that's where we get confused.
Okay.
Okay? Because this, in our symbolic language, is probably not far away from what you're talking about. It just doesn't happen to be exactly the same thing.
Right? Yeah, I guess so, if you can move arbitrarily to arbitrary point, then you don't need next, obviously.
No, but you can define a next, but the next isn't the natural thing necessarily.
Well, I guess my point is that construct that I was showing with those methods basically unifies all these cases.
No, it doesn't. No,
I think
doesn't.
It does. Why not?
No, it doesn't. It doesn't cover these kinds of cases. What you were showing is that, you're showing, look, okay, so primitive operations. You were showing, assume that the primitive operations are, next. What else did you have? You had
basically open close.
Yeah.
Because it's mutable, and something like check next or check.
What's check next? Is there a next?
Is there a next? Yes.
And next itself. Right.
Yeah.
Okay. Fine. We started this meeting up here talking about this. That's a different story.
Well, it can be, it turns out for this particular problem, there is a solution to convert it back to that.
What do you mean?
I mean that you can define, basically, you can find a way to get tuples from, say, thousands to thousands and tens. And therefore, you can obviously also define next as well. If you have that, that's more than next. That's even stronger condition. So you can move through the tuples without even knowing the history. So that's even more powerful.
But let's come back. Let's come back to what we actually wanted to do here. So we've got operations that we want to perform on these things, right? Here. Okay. So we've got things like part, get the kth part. So, let's say I want the 1000th part, and all I've got is a next operation. clearly I just run next 1,000 times and I get the 1,000th part.
Yes.
Right? Now, if on the other hand, it is a form where once I have the 1,000th part, any part that I have in the past is forgotten, then I'm kind of toast if I want to get the 500th part next. Right?
Not necessarily.
Well, yes, you are, unless you remembered what you have. If what was coming was some data from an IoT device and it's gone and you didn't store it, and you say, let me, get in data, let me take the measurement 1,000 times to get the 1,000th measurement, but I didn't remember what I already got, then you clearly can never go backwards. Now, maybe that's not what we're talking about here, but if we're looking at some of these other operations.
Yes, but that's exactly my point. That for example, when I was solving all these problems, trying to solve when I was designing streaming, and that's why I try to separate the iterators themselves, which are sort of sequential one by one, and more complicated data structures like what I have in lazy list, which allows you to not go back because it has certain caching. Or for example, it remembers how many elements were in each chunk, so it knows where to push iterator. So if iterator allows you to move without remembering history, it will remember where to move it next time. And so effectively, it will solve this problem. So
which problem?
The problem that
yes, but you are saving all of them, right? Because
no, in the first place, I'm saving not all of them. Yes,
okay.
There is a cache, but I'm also saving cache. Obviously, is limited, but I'm also saving things like if I chunk data, I'm saving the lengths of chunks. So if I want to just get certain specific, random access to data, I don't have to go through all of the chunks. I know which chunk to pick.
All right, so let me understand. So for example, in the framework that you had, would map thread have worked?
Yes, it does already. I have implemented that.
Well, how many functions have you implemented across your chunks?
I can tell you specifically which. Just give me a second. I'll check. But basically, for really lazy, because there is an eager API and there is a lazy API. So basically, what I have is flatten, join, map indexed part, replace part, reverse, select, transpose, and tuples. But there is a generic framework of how to add more in principle.
So like random choice would be an example.
Well, that one was actually the last one I was implementing. And yes, there is a branch in streaming where I implemented that, but that was a hard problem.
Yeah, I mean, it's like the database randomness problem, right? Where you can't know
somewhat similar.
how to select it until you can see everything.
Yeah, I mean, I managed to get some solution which was reasonably efficient by some clever chunking scheme, but it wasn't trivial.
And it probably depends on some sampling assumptions about the data.
Yes,
I haven't seen the whole data. You can't know that you're getting a random element.
Yes, so I did make certain sampling assumptions indeed.
But so let me just understand it. What you believe you have, if we look at these sources of content, okay?
Yeah.
Okay, you don't have this type of content particularly.
Well, I kind of do because I have implemented tuples. So yeah, I do. But that was specifically for this. For tuples,
but it's true that in any case you will need to do an implementation again for all those functions, right?
Absolutely. So the thing I was showing, this abstract iterator interface, was just a kind of umbrella that allows you to implement specific things. Maybe, Stephen, it won't take you really long. If you just give me a screen, I could show you just a couple more things.
Go for it. Yes.
All right. So there is the you see there are basically, okay, this is this lazy tuples thing, but here someone wanted to get efficient way to implement lazy weak compositions.
Mm-hmm.
So what this guy did, he tried several things, but then finally this is what it took him to implement it and combine it with the streaming. He was using streaming. So he basically just implemented the iterator. It's the same thing as I was showing, but just with his, his own implementation. And then he plugged it in, and after he plugged it in, he could basically get all these things, and he could do, scan or other operations on them just as if they would be built in. And it really doesn't take him long to just this much code to add this to streaming.
This is to your streaming interface, or to
yes. Even though it wasn't documented, but it is in the build, so he was able to actually do this. And then what he did.
Is it in? Wait a minute. Is it in all builds?
Yes, it is in the builds. Right now, it's somewhat broken though, but there is a patch that one can apply. I mean, I wasn't really looking into making it fully working because it was sort of shelved project, but people are still using it. And so what he did next, he did the library link implementation of chunks, and then he plugged those chunks into streaming. And let me show you. He shows that if you don't use streaming, use something else, there are some memory charts, how much memory it takes. But if you use streaming, then he was showing that memory usage goes to a plateau. So it basically, you can see with the streaming, you can do this chunking without the increase of memory. And so, and the same guy did the similar thing with the alternatives to subsets, and he was also using streaming, and again the same thing. So my point is, it's pretty extensible. I'll stop sharing now.
Well, that's interesting.
It's pretty extensible already, so it has been already built for this kind of purposes. That's why I was thinking that maybe if I give a short demo next time, it might be useful.
I find it very hard to understand for some reason. Maybe somebody else here can help me.
Well, I can try make it so that we are not going to drown in details. Just give you a few examples based on this list that you have for sources.
Yeah, that would be useful. That would be very useful. And if what you could do is to take these kinds of sources of content,
yeah, I can,
and these kinds of operations.
Yes, I can.
Then that would be very helpful.
Yeah, I can specifically make a demo centered around these things.
And oh boy. This is the meeting we're supposed to do next, which we're super late for. Let's see. Sorry, I'm just looking at. We have many of the people who are relevant to that meeting already here, right? Jose, is that this is your meeting, right?
Yes. So the two first points we need to do. The others are not so important.
All right. Well, for folks now to not. Maybe we should just segue and change the group of people who are in this meeting and just go and try and handle these points rather than starting a separate meeting for this. And ask the couple of people who are going to join this meeting to join us here, because I think we already have almost everybody. Okay, so then conclusion on iterators. Leonid is going to try and make us a demo based on his technology. And you understand, I think I understand what Ricardo has done here. And you understand that also, right? That there's a procedural operation that pushes things into iterators. Yes? But that's the different idea there, which you may not have.
I'll need to look again at it with Ricardo so that
Ricardo, you're impossible to hear.
Sorry. Yeah, I will send an email to everyone with this thread.
And I didn't really understand how that. I mean, I'd like to see how things worked with tuples with your iterator construct. All right. Well, great. Maybe I'll finally understand everything. I mean, again, the place where we ran into trouble before, as far as I was concerned, and maybe my misunderstanding, was the sources of content problem. But if I think we've now clarified that, I look forward to seeing this. Sounds good. But please communicate with Tom and see if there's something easy that he can do in the data structures project with this. Make sense, Leonid?
Yeah, sure. So can you send this notebook that you just created? Can you send this out somehow
Yes, hopefully. Who is PMing here?
Devin, yeah, I
Okay.
can email it out after the
Great.
meeting.
Please. And were you also PMing the ILD meeting, or is somebody else doing that?
Me too.
Okay, that's what I thought. So, okay, all right. Let's switch people and just a minute. If we can get some if we can get the additional people for ILD in this meeting, then we will just segue to those topics. So thanks to folks who are here for the Iterator thing. We're going to start talking about other stuff now.
Thanks. Bye.
Bye-bye.
Bye.
Okay, we're segueing to this.
Yes, so I think we need Heidi for this first discussion.
Okay.
And yes, so we have, she has some proposals for the new typesetting of a lighter typesetting of data objects.
This is the new one?
Yep, and something below, exactly. So I particularly like it. So that's a current one.
Yeah.
So this middle one looks.
What's the difference?
The granularity is bolder in the lower example. In the one.
Yeah, I understand. Both for input and output, or we're going to differentiate input and output? I think for input it's more like this, and for output it's more like this, isn't it?
Exactly. Yeah.
I mean, unfortunately, by sticking day in there, I mean, you know, Saturday, 6th of June, you don't say it's a day. I mean,
yeah, for days it's very obvious, but I mean, year, for example, we need it. We cannot just put a number.
Right. Right.
Or if we had, I don't know, weeks or something, maybe important.
Did Heidi join us here?
I'm trying to get her right now. She hasn't joined yet.
Okay. Well, the horrifying story of curry.
Yes, indeed. And then two geo things that they haven't shown you yet. So I wanted to. So this is the generalization of the new notation for polygons with holes, generalized to the geo world. So now it supports entities and geopositions, etc. So the idea is that Polygon now can take a rule with the outer ring on the left-hand side and the inner rings.
What happens if there's an island within an island within an island, so to speak? A lake within an island within a lake within an island type thing.
That has to be a different. So, so
the holes, this is a polygon that represents essentially an annulus, and you can't have another polygon sitting inside the hole. Then it's a separate polygon, is what you're saying.
Exactly, yes. Well, I have been discussing with Charles the possibility of having many outer rings on the left-hand side, and then Polygon realizes in real time which is inside which. But at the moment, that cannot work. We need to have separate Polygon.
Well, this is cool.
Mm-hmm. Yeah. So.
Okay, and looks fine to me. I mean, it just has to be documented.
Yeah, indeed.
And presumably, we have geo-entities, famously, you know, the San Marino and Lesotho problem, so to speak. Exactly. We have geo-entities that have holes. And have we now recoded the polygons so that they have holes in them?
Not yet. They are still returned as field curves, which is what we were using before this notation, which was introduced in 12. And yeah, eventually we will change, but we need to make sure that we return to different versions of the Wolfram language, the proper things, because this is from 12.
Yeah, I understand. And do we have that capability from the geo server?
Yes, we do.
And question, how many of the administrative divisions of the world, I don't really remember how many there are, but there are lots, and we're continually updating them. How many have holes in them? Do we know? Is it lots or is it just a few?
It's not many, and some domains actually have not been updated to support holes. So country does support holes, and for example, the main polygon of the world does need holes for the Caspian Sea and some other places. So this is particularly important for country, for the country type.
Yeah, but I mean, what about? I mean, I think there are even cities that have, you know, holes in them, so to speak.
Yes, but what I mean is that we don't support holes in those yet. Okay. We have started with countries. So, but yes.
Why don't
once-
we? What's the difference in the support?
Mm, it's a historical thing. Initially, there weren't holes anywhere, and then we started adding them in countries via field curves.
No, I understand that. I understand that. But what cares about whether there's a hole there, other than the final geo renderer?
No, nothing. It's a matter of curation.
Oh, okay, fine.
Yeah.
And question, I mean, geo area, for example, correctly accounts for polygons with holes, I assume.
Yes, indeed. Yes.
Okay.
Also with field curves.
Right. Okay.
And then this is something you found randomly last week, which is that the regions framework is now able to understand polygons, geopolygons.
Spectacular.
Yeah,
That's super cool.
Yep.
Look at that.
Right, or you have the wall there.
That's really cool.
Mm-hmm. Yeah. And so, yeah, so it's both in terms of graphics and then in terms of computation. So for example, area now knows what to do with polygon of geoposition.
Mm-hmm.
It will take everything in meters. And then in the projected space, it will happen the same thing that we always do. It's in the previous section, which is that it uses the units of that projected space, whether it is degrees or meters.
Sorry. What are you saying?
Yes. So if you go to the previous subsection, yes. So here, for example, there is a little bit further down. There is this example comparing geo area. Yes. So there you see how we take the geo.
The grid position.
Exactly. So area. So
I understand. So the geo grid position is unitless, and it's a pure area. Mm-hmm. I mean, it's implicitly using meters.
Exactly. It's
even in the does the USGS use meters? Everybody uses meters, right? It's not. There's no imperial units anywhere in that world.
Where? Sorry, what do you mean?
In geogrids, nobody is using, miles in some kind of geogrid. Is that correct? It's meters everywhere.
They do. I mean, there are projections in which, yeah. I mean,
okay. So then the geogrid position area could end up being in square inches or something.
Exactly. It's whatever the projection. This is given in this reference model. So the reference model is the one determining what are the units being used.
And how do you find out the units from that reference model?
Because
is it in geoprojection data?
It is in geodesy data. The reference models are geodesy data objects. So if you do geodesy data and then, for example, say ellipsoid parameters or semi-axis, ellipsoid parameters, right? So there you get it's in meters, and that number is a form of giving eccentricity. It's called flattening, inverse flattening.
I see.
It means the.
Is that what it is for the Earth? That the Earth is 1/300th away from being a sphere?
Yeah. So that means the polar axis is 1 over that number shorter than the equatorial radius.
I should have known that. I didn't know that. Okay. All right. Okay. But anyway, this is giving the units there.
Yeah.
All right. Well, this looks great. Is there anything to figure out here?
No. It's just now one can compute, I don't know, region centroid of polygon of geogrid position, etc.
It's wonderful.
It's also that now we will find in many more places polygon of geogrid position also, meaning it has been projected to a map with an explicit projection.
Sorry. We will find what?
Polygon of geogrid position. In the past, we always found polygon of geoposition.
Yes.
But that's an object that doesn't know a projection. So now we support also polygon of geogrid position, which contains a projection.
I see.
Yeah.
Great.
And yeah.
Did Heidi come?
She is here. Yes.
Okay. All right, so the basic thing is to get rid of the cutesy skeuomorphic calendary thing.
Yep.
And the only issue here, really, to my mind, I mean, do we have code that's implementing this? By the way, could we try it on a bunch of cases? You know, I don't know what this is going to look like if you say year : 2015 or something. And what happens when it's like century beginning, you know, how does that work? The weird things with the beginning 1900 and so on versus beginning 1901.
Yeah, I'm not familiar with those examples, so I'd have to.
But Jose, what happens in that case?
It's the granularity label. They will all be written there.
But what will it say? What will it say? I mean,
yeah. So we can do an example like current date.
Okay, so let's do date object. Let's look at the date object here.
Yes. So
how do we get a list of granularities?
It's there. Yeah.
Why did I scrape it? Okay. Okay. So now let's go ahead and say date object of now.
Yeah, or current date of those granularities.
I see. That's what we're doing for these. Probably the least satisfactory of this is the day one. I feel like it still needs something at the
Yeah, so far we only removed the granularity from instant. And that's the difference we are making between we mean the second or we mean the instant.
Okay, so that's what you're proposing for this.
Right, exactly. So that means the current instant as opposed to that second.
I mean, it's kind of obvious that this is a day, isn't it?
Yes. So we could have the convention that for days we do remove the granularity.
I think for months as well. I think for months we could do it too. We could do it for instants, days, and months. Everything else we can't do it for.
Right.
That's what I would propose. And then in terms of the format here, I don't know why this went quite so dark here. I think this lightness, Heidi, and I mean, I don't even know why.
She has a proposal above, which is lighter. So it's just a different proposal.
I see. Okay. And the blueness, what do we think the blueness means? And how does it relate to other blue things we have?
Well, it's kind of random, isn't it? I mean...
Yeah, but blueness tends to mean a link of some kind.
Yeah, I was just taking it from what was already there. I thought color would be a discussion you would want to bring up.
But I don't know what, I mean, what other things do we have that are why did we put this incredibly heavyweight thing in the first place? Does anybody remember?
You know, that's been around longer than a lot of these new icons that we've been adding. So I think it was one of the first. And now I think you would call it a crutch.
Yeah. But so how does this relate to other things? So, for example, the new entity stuff, I don't know who's been designing that. Who's, that's not you, is it, Heidi?
It's been on and off. I did put it at the top of my mock. The entities are just a straight pod with no design. You'd mentioned that.
No, that's a different thing.
Now that you mention entity, yesterday Brett mentioned the possibility of having granularity in the same way that we have the domain, like after and with capitals. Just an idea.
Yeah, I don't think it's going to work well. These are very long words. And I like weak beginning. You know, we're not going to have that as a postfix.
I see.
Week began such and such.
Right.
What I was more concerned with is external identifier and so on. What are you showing us here, Heidi?
Oh, Jeremy put this notebook together when he heard about this meeting.
Well, maybe Jeremy should join us.
Let me see if he's back from lunch. He is.
Could he join us then, please? That's very small font there. Is Jeremy joining us?
Just send
Wait,
him the Zoom link. So.
Yeah, that's a small font. I mean, that matches the X height of these other things. Well, no, it doesn't actually. I think we need Jeremy for this. Okay, the big enchilada, whatever, of this meeting is the curry discussion.
Yes. Your proposal there could be a solution.
Operator applied, reverse applied.
Yes, I do think we need a word operator. So that's why I was suggesting there carry operator, just to make it closer, because this is still very, very close to carry itself. What we all agree on is that the word operator by itself alone is dangerous.
Yes.
So it needs something else. So it could be applied.
I think that if I saw this in code, operator applied F, it would not be absolutely incomprehensible. And reverse applied, what do you think that would mean? I mean, would that mean something reasonable?
The origin of reversed was order. We wanted to use F goes to reversed order to mean in sorting functions that we should use.
Oh, no, I know that, but I mean, so what are you saying? You're saying if I say sort by, or sort rather.
No, sort by a list F arrow reversed apply order. So how does that look? Reversed order looked very nice. And that will be order. So I always liked reversed. Yeah, reversed order.
I mean, the reversed is of the arguments.
Yes.
I mean, it's nice for that case, but what about other uses of reversed?
Other nice uses are products, like you are using the reversed permutation product for some people who want left to right.
What do you mean? How would it help you there? I mean, if
you have.
I mean, if I said reversed of integrate.
No, that's. Yeah, let's use what is another non-commutative product.
Well, what about this? Why isn't it? Why wouldn't this work?
Yeah, no, it could. Yeah.
See, what's a little weird is the reversed is a headdress, so to speak, but it is affecting. I have to say that I think reverse applied might be easier to understand here. Oops.
What about arc reversed?
Arg? Arg. No. I mean, we don't, arg is like for a complex number, you know?
Okay.
Well, you're saying that's hopeless, I think. That seems too weird. Okay, so if we said operator applied of f, it would say represents the function f to be applied in an operator form. That's pretty reasonable.
Mm-hmm.
Reverse applied represents the function f See, I don't understand. Reversed of f represents the function f to be applied with its arguments reversed.
I think this is the sort of thing that we would document by giving the full notation, reverse or what, however we call it.
Yeah, reversed of f of x and y is f of yx.
Exactly.
And what will we do with curry? Leave it as just curry?
I think so.
I mean, it's obscure, but I don't really see any reason to decorate it.
Right. And is it reversed applied or reverse applied?
No, I'm saying we have it reversed. I mean, I'm saying if you think reversed, well, if it was reverse, it would be reverse applied integrate, reverse applied. I mean, I could imagine several other things in this family.
Yeah, we discussed at some point batch applied.
Indeed. Would it work in this family? Does it part of this family?
I think so.
What does it do? It makes sure that the thing is applied in batches.
Yes, so the idea was map of batch applied of f, list. It will apply in batches.
What about curry applied? Gives you some idea what the heck curry, otherwise curry just looks like some kind of Indian food type thing.
Mm-hmm. Mm-hmm. Yep.
Although, I see the currying of curry itself doesn't really fit with curry applied. Curry applied of that fits fine.
Right. Yeah, good point.
But, you know, currying itself is kind of an obscurity anyway. It's not clear that currying itself is going to be the most useful thing.
No, but it was the origin of all this discussion. An advantage of this is that more than a change of syntax of a function, it will be like creating a new name.
Sorry, what?
Yes, I was thinking that rather than a change of syntax in curry, this would be a change of name if we decide to go from curry to curry applied.
Yeah. Look, I actually think curry applied is quite nice because, as I say, if somebody just sees a raw piece of code that says curry applied, okay, they are, you know, it's kind of obscure, but at least they know it's something to do with the way the function is applied.
Mm-hmm.
I might think it means that curry was applied to the function and wonder what curry was.
Well, yes, then you'd be off and running. I mean, that's fine. What do you mean what curry was, as opposed to?
Sounds like you're doing something to F, not necessarily that you're changing how F does things to its arguments.
I agree. Unfortunately, English does not have that distinction. I think reverse applied, operator applied, curry applied. It's my best foot forward on those things.
Why doesn't apply work? I mean, why applied versus apply?
Like apply carried?
No, it's curry apply and operator apply.
Because they mean the wrong thing. Because that what this is doing, Jeremy, is it's changing the way that this thing, it's an operator applied version of F.
Okay.
So it does this.
Mm-hmm.
It's a fairly obscure concept. I mean, it's useful, but it's a fairly obscure concept.
I think apply conveys that idea better than applied does. You're reverse applying F to its arguments rather than normal applying it.
What are you saying?
So if we do reverse apply of F of arguments, I think that communicates what it's doing more clearly.
But we also have apply doing something very different, because this is
See, that
changing
goes to F of yx.
That sounds like you're applying F to its arguments in reverse order. But like Jose said, apply means something slightly different.
We do have now things like image apply, video apply, etc.
Yeah. We can't use apply. Look, the question is whether the thing you are creating is a noun, in which case it is the operator applied version of F, which is what I think we should do, because these things will be on their own. It's, it'll just be hanging out as, reversed of order or something, and you'll just see that thing as a thing on its own, right? So you'll see things like F arrow reversed of order. So F arrow reverse applied of order. I don't think that's terrible. I think that's you have a fighting chance of understanding what that is. I think it's better than reversed of order, actually. It says that's a function and it's reverse applied, whatever that means.
Mm-hmm.
Yeah.
An operator applied here means that. So by the way, is there a second argument to operator applied? Can you say operator applied of F comma Y of X?
No, the second argument is the same as carry, the permutation, number of arguments, this sort of thing.
Is that a good idea? Or should we do this instead?
Well, we do need to have the information of how many arguments it's waiting for.
Why do we think it's more than one?
Well, because we have all these operator forms that take two, like mapat, etc.
What does mapat do?
Yes, we have an operator form of mapat in which you can say f, n, the position, and then the list. You can say 1, 2, 3 there. Map. Yeah.
Okay, so what's your point about that? What you want to do is you want to be able to say operator applied of mapat.
Mm-hmm. And now we would say this would be 1, 3, 2.
1, 3, 2 like this.
No. The permutation 132.
Okay.
Yes, and now you can pass the 3 arguments, f, comma 4, comma list.
Well, or I can do it like that, right?
Yeah.
But I can't put, does operator applied have a 3rd argument here?
No. What do you want? Oh, I see what you mean.
Because I could imagine doing something where I do this, where I say operator applied map at 3, comma, and then even var args, the other arguments.
Well, our original idea was to have all the arguments in additional brackets outside. You could also say bracket f, bracket 4, bracket list.
Sure. No, I mean, in the operator applied form, it is auto currying, so to speak. It doesn't care whether it's got sub-values or whether it's direct. All right, listen, I think we should go ahead and implement operator applied, reverse applied, curry applied.
Okay.
Okay, I think that's the least crazy, after many, many hours of discussion of this, that's the least crazy solution.
Okay, implement that.
Okay, we've got Jeremy and Heidi here. We are talking about data objects. So, Jeremy, this is the complete, where was it? This is the complete inventory of possible modifiers.
Okay.
And my concern on one of these here was that it's awfully your thing here. So these look very small compared to these. There's a very small font, isn't it, compared to this one?
It's reduced, yeah, and we could tweak that, but just to give the overall weight, make the weight a little less, and you could maybe tweak a button and make it bolder, but it's at some point I think you do want the font size a little smaller. Doesn't have to go that small.
Okay. Why do you think we want it smaller?
Just I guess I was optimizing for this list case where it just seemed overwhelming to see that much going on at once.
But I think if there's less in them, if it doesn't have, 10, 14, 55 GMT, whatever.
Yeah.
Is this code that actually runs?
Yeah, this works. So those buttons work at the top. You could flip through those, and then there's code in the styles that you can actually put in your own values.
Very cool, Jeremy. It's very cool. Okay, so if I run that, how do I run this thing there?
Just run it. It's a style sheet, so anything works in that notebook. Yeah.
So high tech.
Perhaps it's the time zone which should be smaller, but not the rest of
Yes,
the data.
that is absolutely true. The time zone should be smaller.
Yeah, I wanted to do that, but couldn't get at it in the template, and so I couldn't do it easily. But yeah, It should certainly be a little smaller.
Yes. I think that going this small is unnecessary. And I think that if we can bump up, let's see, what is this?
Is that working? Yeah, it's working. Okay. So if you open up styles, there's a chunk of code that you can just tweak the font size, and we could look at it.
Is this bold here, or is this?
It's demi-bold, but it's not much heavier weight than what we have now, and it definitely felt matching our, the ambient font size was too much in this case.
Ali in our live stream is complaining about the non-readability of things like reverse applied. The fact is, things like that, I would like to provide the cautionary tale, okay? // super useful, even though the first time you see it, it's kind of obscure. The point of these things, it's like @*, which I'm just starting to really use seriously myself. These things, once you get used to them, are super useful. They are quite obscure. The first, and I'm afraid that one, when you see it, you kind of know it's some kind of function decomposition thing. The goal with things like, operator applied, is there are cases in which it's just a really convenient way to think about it. And the goal is, if people see that in a piece of code, They're not totally confused. If they really want to know what it is, they mouse over it and they look at what it does. But I feel like that is it's a self-explaining thing, that it is something to do with the way that the function applies itself to arguments. And I'm actually fairly happy with it. Might be wrong, but I think I'm fairly happy with it. Okay, anyway, back to Jeremy's. Was this, wait a minute, is this yours? Yes, this is yours.
Yep.
So what are you proposing here?
Yeah, open styles, there's just a small chunk of code there. The color's weird, but if you change that second argument, 12 to 13, that'll be a little larger font.
Why did it go?
It picked up your red finally.
Yeah, it's the color's weird.
What should I do here? I should say.
Well, it'd be hard to pull out that value. I mean, I think you could just tweak it for now. Yeah, this way.
Now that's still bold.
Yeah, and there's a setting up there. You could just set it to plain, I think, instead of demi bold. So plain without quotes instead of demi bold up there, and that'll work.
I'm not horrified by the demi bold, by the way. So let's just copy.
Yeah, it depends on font size. I think it works as long as the font size aren't too big. Yeah.
Gosh, I don't know. I mean, this is the 13-point type. Is that right?
Yeah.
Well, I definitely think that's better.
Okay. Well, maybe this with the dark blue and the smaller time zone. I think demi bold's going to be overwhelming here.
Yeah. Okay. I think this is good then. I'm good with that. I mean, you know, in terms of color, I think the sort of slightly off black is in some direction is okay.
Mm-hmm.
And I think we're planning to drop where it says day. We're planning to not have it say day. Okay, so we're going to drop day, month, and instant, so to speak, right? Because they're self-evident. Does that make sense?
Okay. Yep.
And otherwise, I think this looks good.
Which one is instant? Instant.
The last one. The last one here.
Okay.
That means the span of the whole second 14 past the minute, whereas this is the actual instant in time. We could segue to my other project and discuss what that might mean, but that's a different issue. Okay, those hyphens, do we believe in them being the same font and weight as the other stuff, or do we think they should be different? And do we believe that this is the right sizing? We could go down a point for this, maybe.
Yeah, since we've gone up on the rest, I could see that coming down too. And I think the dash shouldn't be that dark. It could be gray again.
Fine. Okay. Okay. Looks good. Let's do it.
Great.
Steve on our live stream is complaining that the @ operator is poorly documented. I agree with that. Ah, sigh. I mean, it's so hard to document a thing which is, you know, like just generic. It's like it doesn't. I guess that these days we could document that the @ operator is short for construct. Except I'm not even sure that it is. I mean, if we held the thing, it probably wouldn't be.
Exactly.
It's all the flavors of that though that get weird, right? You combine it with other characters and they do different things. That's the weird part for me.
Yeah, I mean,
pretty quick.
It does get exotic quickly. I mean, but you know, I use /@ I use @, I use @. I mean, but again, they're acquired tastes. Like this one, you know, we introduced this a few years ago, and I'm only just starting now to really use it in a serious way. And it's very useful when I actually use it.
But evaluation is important here because f at x evaluates both f and x, but f at x does not
Yeah.
evaluate X, while
Yeah, I
construct
understand.
fx does.
Right. It's a bit of a can of worms. And our syntax table from the original book certainly handled this, but I'm not sure that we have a great place in existing documentation for these things. It should be passed. Devin, if you could make that comment to the documentation people again, I'm not sure that we have a great solution though.
Sure.
Okay, I think we finished just in time here. So we got through our whole agenda, didn't we? Look at that.
There is a final topic there, but let's leave it for another day. Let's leave it for another day. It is a long thing.
Oh no, that's a huge. Yes, that's a huge topic.
Yes, it's an interesting topic, but for another day.
Right. Okay. Thank you all very much. Thank you to folks on the live stream. A lot of great, very useful comments. And see you all another day. Talk to you soon.
Bye.
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 Thanks,
Bye.
bye.